In this lecture, we will discuss left arm right leg lead reversal and how to identify it on the EKG. Making sure that the EKG leads are connected to the correct electrode position is important for getting accurate rhythm strips in 12-lead EKGs. If the leads are reversed, we call this lead reversal, and it can often produce EKG abnormalities. It's important to be aware of these accidental misplacements of the limb lead electrodes because they can often mimic various pathology, including chamber enlargement, ectopic atrial rhythms, or even myocardial ischemia and infarction. Now, when the limb electrodes, that is the left arm, the right arm, and the left leg, are exchanged without disturbing the neutral electrode, which is the right leg, then Einthoven's triangle is flipped 180 degrees or rotated. This results in leads being switched in position, becoming inverted, or remaining unchanged. It depends on their initial position and the vector. Remember, the goal is to be able to see why these EKG changes occur and then be able to reason them out on your own instead of memorizing anything. We'll also mention a few things to look out for in order to spot this left arm, right leg lead reversal. Okay, so what we have going on here is we're saying that the left arm and the right leg electrodes are being reversed. In this case, Einthoven's triangle collapses to a very thin slice with the right arm electrode at its apex. Okay, so let's take a look at this. So here's our left arm. This is our right leg or neutral electrode, and we're saying that they're switching places. So now the left arm will come down here, okay, and the right leg or the neutral electrode will come up to where the left arm is, okay? So you can see that here's the right leg or neutral electrode that comes in that position, okay? And now we have our left arm down here. And you can see now we get this Einthoven's triangle is collapsing into this thin slice, and we said that the right arm is at the apex. Here's our right arm, and you can see now it's at the apex of our triangle, okay? Now the left arm and the left leg are now recording identical voltages, okay, making the difference between them negligible. That is, lead 3 becomes a flat line with zero potential. So let's look at this. We have the left arm, which is now down here, and the left leg, okay? Remember, between our left arm, let's just see this. Here's our left arm and our left leg. Notice what's between left arm and left leg is lead 3. So lead 3 now becomes in this position, okay? Remember, imagine our heart sitting right at the center of these, okay? And now we're moving it, this left arm down here, okay? So imagine like our heart here. Okay, so now everything's shifting outside of that. So if our left arm and left leg are here, pretty much you're going to record a zero potential. They're at the same level. Okay, so because of that, we're saying that lead 3 becomes zero potential or a flat line. So here's lead 3. This is the normal case, and this is what happens when we have this left arm, right leg reversal. Okay, lead 3, which is now here, becomes a zero potential, and you see pretty much a flat line here. Okay, so lead 3 is a flat line, and that's something to keep in mind in distinguishing it from other types of lead reversals. Additionally, lead AVL and AVF are essentially mathematically identical, such that they appear identical on the EKG. Okay, so let's look at lead AVF and AVL, which are also down here. So here's AVL, which is from our left arm. So notice AVL is here. Now it's becoming down here, and it's at the same level of AVF. Okay, because they're at the same level, I'll just erase that so you can see that. So we have AVL and AVF at the same level. They're going to appear pretty much identical. So here was AVL and AVF. Okay, and now you can see that they're pretty much different than the other EKG, so they're different from their original, but they're identical. So AVL and AVF are pretty much the same, okay? So again, that's AVF and AVL, and we saw that lead 3 is that zero potential. Now lead 2 is going to be unchanged. This is because the right arm and the left leg electrodes are not affected. However, AVR will run within this thin slice and will face approximately opposite to lead 2. Therefore, AVR is nearly an inverted lead 2. So take a look here. Here's lead 2, okay, going from the right arm to the left leg, and it's really not disturbed, right? Our right arm and left leg are still there. Here's lead 2, still going in the same direction, okay? So lead 2 will remain unchanged. It's the same as it is here. And we said that AVR is pretty much going in the opposite direction, okay? Notice this is AVR, and this green arrow here is going in the opposite direction. So lead AVR pretty much equals a inverted lead 2, okay, going in the opposite direction. So here's AVR, and then we're pretty much seeing an inverted lead 2 in that case there, okay? So hopefully that makes sense. And lastly, leads 1 and 2 become identical because they are directed in the same direction and nearly identical when the left arm electrode moves to the right leg electrode's position. So here's our lead 1, okay? Lead 1 going from the right arm to the left arm normally, okay? And still going in this case here. Here's our right arm, and here's our left arm as it comes down in the right leg neutral's electrode's position. And lead 1 will be right here. And imagine it's still going from our right arm to our left arm, and it's pretty much traveling in the same direction as lead 2, and because of that they will be recording pretty much the same thing. So again, here's lead 1, okay, and you can see it's pretty much recording the same thing that we see in lead 2, okay. Now one final thing to be aware of is that the precordial voltages may be distorted because the right leg or neutral electrode has been moved. So anytime you move the right leg or the neutral electrode, it can distort the precordial lead voltages. So that's leads V1 through V6, okay, so you may see some changes there. All right, so let's briefly review what we discussed before we end here. So this is a left arm, right leg reversal, and this is when the Einthoven's triangle is pretty much collapsing and we have the right arm at the apex. Okay, here's our right arm at the apex. Okay, and remember we're taking our left arm here and we're moving it down to this right leg neutral electrode's position. Okay, so the main thing you see is that lead 2 will remain unchanged. AVR will become inverted lead 2. We'll see a flat line or zero potential in lead 3, so that's an important thing to keep in mind and can help distinguish from other things. So notice lead 3 here can really point you towards that. And then we'll see that leads 1 and 2 will be identical, and same thing with AVL and AVF. And remember, moving that right leg or neutral electrode can distort the precordial lead voltages, okay? Well, that's the end of this lecture. We discussed left arm, right leg lead reversal and how to identify it on the EKG. I hope you learned something.